So now that we know some trig identifications, we're going to move on to verifications. And what verifications are is they're kind of similar to a geometric proof. In other words, the problem's going to ask you to verify something, and they're going to give you something and tell you what to get to. Now, the choice is yours, actually. It's like an equation, so one can equal the other. But just like in geometry, you're not allowed to use both sides. You can only use one side. You have to work from one side to the other. So this verification is not that bad because you always want to look to deal with the hardest side because you're trying to simplify that and make it easier. Now, in the problems we just did, the simplifications, you didn't know where you were going. Now you kind of know where you're going. In this case, we're asked to take this stuff and make it into a cotangent squared. So we know where we're going. And I can kind of, in my head, visualize what cotangent squared looks like. That's cosine squared over sine squared. So let's see if we can do that here. So in the first case, one way to do this, like I've told you, is to make all one side sines and cosines. And we'll do that here. So this is 1 over sine times cosine over 1 over cosine times sine, which is really cosine x over sine x over sine of x over cosine of x, which is just basically a complex fraction, so I'm going to multiply by the reciprocal. So this is cosine x over sine x times cosine x over sine x, which is cosine squared x over sine squared x, which is cotangent squared x, which is what I was trying to get back to. All right? So that's how verification works. We'll do some more. So in this problem, this side looks to be the most difficult side. This side is the easier side. This is basically 1 over cosine plus 1 over sine. I can go ahead and change all this if I want. Doesn't really matter. Let's go ahead and do it. So this is sine. I'm going to actually FOIL, I think. Sine tangent plus sine cotangent plus cosine tangent plus cosine cotangent. So now I'll change everything to sines and cosines. Let's just go sine x over cosine x, sine x cosine x over sine x cosine x plus, oops, sorry, times, let's go, that's sine x over cosine x and cosine x times cosine x over sine x. So you're going to see there's lots of reductions I can do. This goes to sine squared x cosine x. The sines go, leaves you with cosine of x. Cosines go, leaves you with sine of x. And let's see. This goes to cosine squared of x over sine of x. So it looks like I'm going to need to do a little bit of work here. There's my something over sine, but that's not really helping me much. I'm going to take and go ahead and get a common denominator. Let's do this as a common denominator. So I'll say this needs cosine over cosine. Let's say this equals sine over sine. Going to add the cosine term, so that's sine squared plus cosine squared over cosine and sine squared plus cosine squared over sine. And notice what's going to pop out here. These are Pythagorean identities, both of which equal 1. 1 over cosine, 1 over sine, which is secant x plus cosecant x, which is what I was trying to get to. Again, this one's an easier one because you know exactly where you're going to sine squared of x, and I've got a Pythagorean right here. 1 plus tangent squared is secant squared, so this is tangent squared x over secant squared x. Secant, I know, is equal to 1 over cosine, so that's tangent squared x over, actually, let's just do this while we're at it. I'm going to make that tangent squared sine squared over cosine squared over secant squared is 1 over cosine squared. Multiplied by the reciprocal, sine squared over cosine squared times cosine squared over 1. The cosine squareds go, leaving you with sine squared, and end of story. So now you have to figure out what's going to be your most difficult term to deal with. It's kind of up to you. I don't know. Sometimes I think subtractions are more difficult than a multiplication. So let's go ahead and do that for the heck of it. We'll work on the right side this time. So tangent is equal to sine squared over cosine squared minus sine squared over 1. So now I need a common denominator. So I have sine squared over cosine squared. I'll multiply this by cosine squared over cosine squared. So that gives me sine squared cosine squared over cosine squared. Notice I can add these up and I get cosine squared. Or actually that's sine squared, sorry. Let's change that. Sine squared x minus sine squared x cosine squared x over cosine squared. Notice I can factor this because they aren't like terms, but I can pull out a sine squared. And I'm left with 1 minus cosine squared, which should be ringing some bells at this point. I know that sine over cosine, or sine squared over cosine, is tangent squared. And I know that 1 minus cosine squared is sine squared. And notice what we're trying to get to. So in this case, I'm probably going to take and factor. It doesn't matter which side. I'll pick, yeah, it really doesn't matter. I'll take and pick this side over here. I get 1 minus cotan squared x and 1 plus cotan squared x. The problem is I need to get all this into cosecants. And I know 1 plus cotangent squared is cosecant squared of x. So that is perfect. Now this I've got a little bit of problem with. 1 minus cotangent squared isn't anything, but I do know that cotangent squared, since I know 1 plus cotangent squared is cosecant squared, I could say that if I keep my 1, and then instead of saying cosine, we know this. Let's just put it over here so you can see. So there's your Pythagorean identity. Now, if I were to take and isolate cotangent squared, as I've done before, I subtract the 1. So now I have 1 minus cosecant squared of x minus 1. Put that in parentheses. For some reason this went away. I don't know why. So now I'll take and distribute that, and I have 1 minus cosecant squared x plus 1 times cosecant squared of x. And that goes to 2 minus cosecant squared of x times cosecant squared is equal to 2 cosecant squared of x minus cosecant to the 4th of x, which is right there. So here's where you get stumped. In this problem, we don't have any Pythagoreans, and we can't change the sines and cosines because everything is in sines and cosines. When you're completely stumped, what you want to do is you want to multiply by what we call a clever form of 1. So I want to multiply by something that changes the look of a side but doesn't change its value, and the only thing we can multiply by to do that is 1. And typically you're going to do these with binomials. Typically, not all the time, but typically. So I notice that I've got a 1 plus cosine here, I got a 1 minus cosine there. And I need a 1 minus cosine. So I'm going to say, well, my clever form of 1 is going to be 1 minus cosine of x. And if I put 1 minus cosine of x over 1 minus cosine of x, then that's 1. Now, it just so happens that this is the same first term and the opposite of the second term, which is a conjugate. Also, we learned that in radicals. So now, here's what I'm going to do. I'm going to say I've got sine times 1 minus cosine of x over, I'm going to FOIL this, and I get 1 minus cosine squared of x. Now I also know 1 minus cosine squared of x is sine squared of x. So I have sine of x times 1 minus cosine of x over sine squared of x. Sine over sine squared happens to be sine. And what do you know? We got to where we wanted to go. So again, when you're completely stumped, out of luck, can't do anything else, multiply by a clever form of 1, and many times it's going to be a conjugate. So those were a couple examples. Again, to do these, you have to know your Pythagorean identities and your reciprocal identities and then be able to manipulate algebraically.